Hello everyone. In this exercise, we're going to use different reagents to test for the presence of macromolecules. So I have two tests that we're going to start with. The Biuret reagent will test for the presence for proteins, and Benedict solution will test for the presence of simple sugars, which we can also refer to as monosaccharides or reducing sugars. Okay, so to start, I have labeled 10 test tubes, two sets of 10s. First row here I'm going to use for my Biuret reagent, and the second row is going to have the Benedict solution added to it. Now for both of these tests, it's important to have controls. So then we have a clear comparison of what a negative result should look like compared to what a positive result should look like. That way we know that our test is valid. So I have made a list of what's going to go into each number tube. That just saves me the hassle writing out each item on the tube. So in my number 1 tubes, I'm going to add 2 milliliters of water. Number 2 is going to be glucose solution. We know that glucose is a simple sugar, right? So that's going to be a positive control for the Benedict's test. And it can serve as an additional negative control for our Biuret reagent test, okay? Because glucose is a carbohydrate or monosaccharide, it is not going to be positive for the presence of protein. The next tube is going to get albumin solution. Albumin will serve as a positive control for the Biuret test. Albumin is protein that comes from egg whites. Okay, so 2 milliliters of that. Going to add into test tubes number 4, starch solution. Starch is a polysaccharide, so that is not a reducing sugar. In number 5 will be sucrose. Sucrose is a disaccharide. It's used as table sugar. So I'm going to add 2 milliliters of 1% sucrose into my number 5 test tubes. All right, so next I'm going to get into some food items that we'll test. First, I have peanut butter homogenate. All right, so that's number 6. Number 7, we're going to test milk. Number 8, I have onion homogenate. Next, we have banana. It's a little bit viscous. All right, and in my last tube, I'm going to add potato homogenate. Okay, so now I'm going to add a dropper full of the Biuret reagent in my first row of tubes. Okay, so each tube is going to get a dropper full. And you'll notice that I'm not going all the way into the tube. I want to be careful not to contaminate this dropper. Some of them you've noticed a color change. So after I get the Benedict solution added, I'm going to go ahead and heat up those tubes. So that test actually requires heating up the reagent for 5 minutes. Sometimes you can see the color change much quicker than that, depending on how high the amount of monosaccharides is. And then during that time, we'll take a look at our results for the Biuret test. Right behind me, I have a hot water bath. It's not quite boiling, but we'll get it up there. Just gonna gently give these a swirl and then place them in there. Wait about 5 minutes to take those out. And let's take a look at our Biuret test. So again, our negative control looks as it should, just has a light blue tint to it. Number 2, we also expected it to be negative since it's a glucose solution, which is a carbohydrate, not a protein. Our albumin solution, that's a clear purple color, right? So if we compare the negative control to the albumin, we can tell the difference between the two. So we know our test is working. Starch solution has a light blue appearance. I don't see any violet hue. So I want you to notice that positive or negative for proteins. Number 5, sucrose, also no purple hue. That's our table sugar. The peanut butter, now I can see a violet hue, right? We know peanut butter is a good source of protein, so we expect that to be positive. All right, number 7, that's our milk. What do you think, positive or negative? Next we have onion. Number 9 is banana. So I'm not seeing much of a color change there. All right, next we have the potato. This one's a little bit difficult to tell because it almost looks slightly purplish. It's like a murky brown. Doesn't appear to look much different from the stock solution. Okay, so again, I'll post pictures of these so you can look at them carefully and fill out a table of indicating which ones were positive and which ones were negative. Okay, so that completes our test for the Biuret's reagent, which again tests for the presence of proteins. Okay, so it's been 5 minutes. Let's go ahead and take a look at our Benedict's test. These are really hot, so I'm going to take them out using this clamp. So again, number 1 was our negative control, right? That's just water and the Benedict's reagent. Number 2, which had glucose solution, that looks very different from our negative control, right? So that glucose is a simple sugar, a reducing sugar. So that's giving us color change to a reddish orange. Our albumin solution, right? Albumin is protein. That's not looking orange or red. Starch solution, okay, so we don't have any orange color there. Why? Starch is a polysaccharide. Remember, the Benedict's test is only going to detect simple sugars, monosaccharides. Now, sucrose is a disaccharide. Still, that doesn't act as a reducing sugar. It's still not a monosaccharide. It's 2 monosaccharides linked together through dehydration synthesis. So we get a blue color indicator. So no orange color, meaning that it's negative for the Benedict's test. Next we have peanut butter. Actually, this is looking negative. This is more of a peanut homogenate. It's not the peanut butter we would typically buy like Jif or Skippy, which probably would be positive for sugars. But again, not really seeing an orange appearance. Next is milk. What do you guys think? Looks pretty orange, right? Onion. Not a whole lot of oranginess to it. Okay. Number 9 is banana. A bit difficult to see, but the bottom of that actually looks very orange. then we have potato. That's actually looking orange also. Okay, so that's it for the Benedict solution test. I'll go ahead and take pictures of those and post them. And you can expect to see questions for you to interpret these results and test your understanding of macromolecules.